Good evening everyone, welcome to one problem per day portal. So this week we will be solving problems on relativity theory. We will see 5 problems on this. Okay, let us begin with the first one, and this problem is for 6 marks, so I have allotted this for 6 minutes. Okay. Now two muons are moving parallel to each other with the same velocity relative to the ground. Okay, so there are two muons moving at the same velocity over here. Okay, then in the frame of reference in which the muons are at rest, which means what? Where is it their rest? So if I am an observer sitting here, I observe this muon is at rest with respect to me because we both are moving at the same velocity. The force between them is a repulsive electric force, definitely, because there are two like charges. Okay, so both the muons are seen to be positive charges, and as a result of it, they will start repelling each other. Okay, so they try to go outside like this. The forces are acting like this. And explain for the reference frame of the ground why there is an additional magnetic force across them between the muons. So with respect to the ground, if there is one more observer standing here, okay, for him it's not only the electric force, there is also a magnetic force being observed. What is the reason? So how do we explain this? Now the question is very simple. When I say that there are muons which are moving in this direction, then this is equal to something like a current carrying conductor, right? A current carrying conductor will also have a current in this direction, positive charges. So there is a current carrying conductor here, there is a current carrying conductor here. Let me call this as I and I over here. When there are two parallel conductors over here, what will happen? There is always a magnetic force between them. How is the magnetic force? Magnetic force is always attracted towards it, right? So what should we write here? That's the next question. Now we should say moving muon produces moving muon is like a current carrying conductor. Therefore, two parallel current carrying in the same direction produces an attractive magnetic force. Okay, this is 1 mark, this is 1 mark, so finally we get 2 marks. Okay, so of course it's 1 mark, so you can generally have written for 2 marks, you can get 1 mark over here. Then whether the electric or the magnetic force has greater magnitude, obviously it is an electric, because in the rest frame, if there is an electric force has a greater magnitude, so magnetic force is 0. So here if there is a magnetic force, electric force should also act, so that in both the frames the same type of force has been observed. So it is the electric force that has a larger magnitude. Okay, then next is in muon decay experiments, muons produce high in Earth's atmosphere move towards the ground at speeds close to the speed of light. Okay, there is a muon which is created here in the Earth's atmosphere. They are moving with a speed which is very nearly equivalent to c over here, Detectors on the ground record the arrival of the muons, outline how these experiments provide support for time dilation. Okay, so what happens is the muon's lifetime is very low, which means what? If you sit on the muon, then the muon's lifetime is very small, of the order of a few microseconds. It immediately dies off, or it just decays, or it gets converted into electrons. Okay, that's what it should happen. Okay, but on the other hand, to a distance of something like around 3 kilometers, I observe that the muons are still been existing. Okay, it reaches the earth, which means what? The lifetime has increased. Okay, and as a result of it, more muons reach the ground. Okay, now these are 3 marks. First one is you need to mention this one. Second one, the lifetime has increased since more muons reach the ground. Okay, so this implies in a moving frame, time has in a moving frame time is same, in a stationary frame as observed in a stationary frame. Write it like this: as observed in a stationary frame. time has increased. Time has increased, which means it is nothing but a case of time dilation. This is a case of time dilation. Okay. So with this we come to an end to this particular problem. So if you have any questions on relativity, you can visit my website. So wherein I have put one complete course on only on relativity, or you can also visit in the playlist. You can observe there is a course on relativity itself. Four or five lectures have already been uploaded. You can look into it. The rest 2 lectures will be shortly uploaded. Okay. So thank you very much.